Hi and welcome back everyone. For you who just joined, welcome to the AlphaSoft Online C++ Demo Day. As you might hear in the background, it's 12 o'clock. So my name is David Farnabo and I'm the product manager for development tools here at AlphaSoft. For you who don't know, AlphaSoft is a leading provider within development and research tools in Europe. If you have any questions about the tools our presenters during the day has been talking about, you're more than welcome to contact me. You have my contact details in the right corner of the presentation slide ahead of you. Today's final session is called Using C++ Builder for C++ Development and will be presented by Al Manarino. Just a little housekeeping before we get started. If you have any questions during the presentation, please type them in the chat in your GoToWebinar panel on your right side. We will try to answer your questions on the fly during the presentation, but if it doesn't fit, we will take them during the Q&A at the end of the session. Now, without further delay, we'll turn the time over to Al Manarino. Our presenter today is an Embarcadero C++ Senior SE. With that, I'll hand over the screen to you, Al. Best of wishes and good luck with your presentation.
Thank you, David. All right, just checking if you can see my screen.
We can see it perfectly.
And you can hear me okay?
Very good. Okay,
Wonderful.
Go ahead.
Thank you. So hello all and welcome to this C++ Builder overview, presentation, and demonstration. My name is Al Manarino, and I'm one of the Embarcadero software engineers. For the agenda, the goal of this session is to give you an overview of using C++ Builder for C++ development. Specifically, we are going to look at these three different levels of development you can do with C++ Builder. The first level is called using components. So C++ Builder includes hundreds of pre-built components for rapid application development using either the Windows-only framework we call the Visual Component Library, or VCL, or using the multi-device true native components we call the FireMonkey, or FMX framework. Now, the second level of C++ development using C++ Builder is using common libraries, and the common libraries are included as part of the runtime libraries. And the third and the most low-level C++ development is using platform APIs, also known as being able to touch the middle of the devices. So for those of you who may be new to the C++ Builder IDE, what is C++ Builder? So C++ Builder is both a C++ IDE, an integrated development environment, plus a full stack solution for C++ application and server development, with features C++ developers really love, especially being able to design, code, debug, and test applications for cross-platform deployment with native performance. And for platform independent and cloud ready, C++ Builder is a rapid C++ cross-platform application development toolset for native Windows, Mac, Android, and iOS development with broad cloud and IoT support. And this also includes integrated components to access cloud-based backend as services and REST services, and easily deploy stateless, RESTful, scalable, and secure turnkey middleware solutions to mobile enterprise applications. And C++ Builder features Clang enhanced compilers, and C++ Builder has C++17 support with additional flags for the C++ compilers. So first, let's look at C++ development for the Windows-only platform using VCL, Visual Component Library components. And by Windows only, we mean only being able to use these components to develop Windows 64-bit and Windows 32-bit types of applications. So now let's look at an example on how to use C++ Builder with the VCL framework. So here we're looking at C++ Builder version 10.3, and we can see from the main welcome page that you can create new Windows VCL applications for C++, or you can create new multi-device FireMonkey applications from C++. So let's start and create a new Windows VCL application for C++. So here we get a new project with a blank form, and we can see from the target platforms, in addition to the default Windows 32-bit, we can also add the Windows 64-bit platform. So since this is a Windows-only VCL application, the only two target platforms we can target are either Windows 64-bit or Windows 32-bit. So the first thing I want to do is save my project so I'll be able to find it later. So File, Save Project As. I will put it into a new folder. I will call this my Say Hello project. So the first thing we get to do is name our main CPP file. So I'm going to call this my unit main. Next, we get to save our pre-compiled header file. I'll also call this my Say Hello file, pre-compiled header. And lastly, we get to name the project. So I will call this again my Say Hello project. So by doing this, we now have our Windows executable name, which will be Say Hello, .exe. We have our main CPP file, and we have our pre-compiled header file. So we want this application to be our Say Hello application. So basically, we want the user to be able to enter their name in an edit box and then push a button and then have a label say the word hello plus whatever value the user entered into the edit box. So to do that, here's our tool palette with hundreds of pre-configured components we can use to rapidly build the application. So I'm first going to search for an edit box, find it, select it, and add it to my form. Next, I'm going to search for a label, find it, add it to my form, and position it any way I want. And lastly, search for a button and add it to my form. Now, as we can see here, each one of these VCL components has properties and events that we can set. So for example, the button right now, the caption on the button says button 1. But let's say we want to change the caption, so I can search for caption and change the caption from button 1 to the word Say Hello. And by changing it here in the Object Inspector, it also changes it on the button. And another quick way to make changes to these components is simply right-click on the component, select the Quick Edit function, and say change the text from Edit 1 just to be blank. So again, we want the user to be able to enter their name in this edit box, click on this button, say hello, and then have the label say the word hello plus whatever name they entered in this edit box. So we see this button, say hello, has an event called onClick. So here's the event handler for the button click. So we see now that code completion is working. So code completion is asynchronous, meaning if I know what to type, I can type ahead and continue completing my code, or I can wait for code completion to complete to give me some idea of what I need to type. So in my case, I'm looking for the field called label 1. So I can select it from code completion. I want to change its caption. So as code completion is working, it says the property I need to select is caption. So label 1 caption, I want to be equal to the word hello plus whatever text I decide to put in the edit 1 box. And let's just finish it with an exclamation point. All right, so that should be all I need. So now if I go back to the designer, I can highlight this as a Windows 64-bit application, build and run it. But by default, it'll run with the default Windows styling, meaning it'll show up as this boring gray and white form. So the first thing I want to do is add a new style to this application to make it look more modern and more new. So to do that, I can select Project, Options, under Application Appearance. Here we see about 30 default styles I can add to my application. So I'm going to pick the Windows 10 Dark style. You can preview it to see what it looks like, so very nice. So now let me build and run this application, and it will run as a Windows 64-bit executable. So here we see the project compiling. So far, no errors, no warnings, no hints. So far, all is good. Next, we have the linking. And now the application gets created. And now we see it running with this nice looking Windows Dark theme. So now I'll type a name in the edit box. I'll call it C++ Builder. So now when I click on the Say Hello button, we see the label now changes to Hello C++ Builder. So all of that worked fine. So this is the benefit of using components for rapid application development. So you add a few components to a form, you set a few properties, you write some C++ code, and then you can rapidly create Windows applications using the VCL framework. All right, so that was a quick look on how you can use VCL Windows-only components with C++ Builder for rapid application development of Windows-only applications. File, close all. All right, next we're going to look at using the C++ Builder multi-device framework we call FireMonkey, or FMX for short. So C++ Builder creates true native multi-device applications for the same single user interface using the same single C++ code base for Android, iOS, Mac OS X, and the Windows platform. And by native, I mean the applications are completely native to the device, meaning you have no interpreters, no scripting language, no JavaScript, no HTML5, and no virtual machines. These are true native applications compiled, let's say, to the ARM chip of iOS or to the ARM chip of an Android device. So now let's take a look at how to use C++ Builder with FireMonkey components. So back into our C++ Builder IDE. Let me bring up a FireMonkey application. So here we have a C++ Builder multi-device FireMonkey application. So now when we look at the target platforms, in addition to Windows 64-bit and Windows 32-bit, we can now build and deploy this for Android, iOS, Mac OS X desktop, in addition to Windows 64-bit and Windows 32-bit. Another nice advantage of being able to do this is, so currently I have an iPad Air 2 USB connected to my laptop. So this will allow me to build this application as an iOS 64-bit device application and install the application directly onto my iPad Air 2, because I'm running this now in development mode. So this is an application that allows the user to display their location of their device on a map and then save it for future use. So this application also shows how to use geocoding location data in a mobile application using the FireMonkey components. So I would say the single most important concept to understand with C++ Builder cross-platform programming would probably be the concept of using styles. So here we see in the IDE, you have a drop-down called style that's currently set to iOS. So this is showing me what all of these components and controls would look like when running on an iOS device. So for example, here we have a button that's styled for an iOS device. If I now change the style from iOS to Android, we see how the button type changes specifically for an Android device. And the same applies if I create a Mac OS X desktop version of the application. We see what the button would look like running on a Mac and also for Windows. But for now, I'm going to select iOS. So here's my button for iOS. So every one of these controls has a property called style lookup. So we can see now, for example, for this button for iOS, right now it's set to use the back tool button for iOS. But as you can see here, all the possible button types for iOS appear here that I can pick and use for this button. Could be the camera tool button or the delete item button. And the same apply for Android, Mac, and Windows also. So now, in addition to having FireMonkey UI components that we see on this application, like a button, a switch, there's a list box with list box items. I also have a multi-view component that works like a sliding drawer to show and hide information, similar to what you would see on your Contacts app on your iOS or Android phones. I also have a web browser component that we are going to use to display a map of where the device is located. And this application also has a location sensor component on the device. So the FireMonkey framework also includes device sensor components like a location sensor, motion sensor, and orientation sensor. So this location sensor will give us the GPS position of the device. So this will give us the latitude and the longitude of the device. Plus we can also get geocoding information from the location, like the country code, the country name, the locality. It'll even give us the street name and the address of the street where the device is located. So now let me quickly build and deploy this application as an iOS 64-bit device, and then we'll come back into the application and see how it was created. So I'm simply going to go ahead and click this green arrow button here, which will build and run the application and deploy it to my iOS 64-bit device. So here's the compiling part. So what's important to note now, this is now going to create a native iOS.app file. And since I'm USB connected to an iPad Air device, it'll actually deploy the application to my iPad device, and then I'll show you it running on my iPad Air device. So there's the linking process. Here's the deploying process. Here we're packaging up all the pieces we need to create the native iOS.app file. It'll sign the app, provision the app for me, and then here we see the .app file being created and launching, meaning it's now moving it over to my iPad. Let me open up my iPad. So once it completes deploying to my iPad, I'll switch to screen share and show you what this looks like running on my iPad. So again, the key important piece here is this is going to be a native iOS.app file with native components. So it's on my iPad now. So for you to see what I'm seeing, I'm going to use this utility called Reflections to share my screen. Screen share. Okay, so got unable to connect. So let me see. I'm running here. Let's see, reflector. All right, now it's happy. So assuming you could all see this, this is my iPad Air 2. It's an iOS 64-bit device. So here we see the application running on my iPad. We see in the upper left-hand corner, there's a button here. You know, I like to refer to this as the hamburger button or the veggie burger button, whatever your preference is. So let me first click on that button on my iPad. And we see it slides out the multi-view component to expose that we have the switch here to turn on location services. So I'm going to activate the switch on the iPad, and we see it immediately picks up the latitude and longitude of where this device is running. So right now I have the application in vertical mode, the iPad in vertical mode. So now if I switch it to horizontal, we see the application already understands orientation and changes the screen to support the landscape. So here's the map displayed on the web browser component. So it shows I'm here in New York on Long Island in a town called Coral Place on a road called Knollwood Drive at address 71 Knollwood Drive. So all of this is working just fine. All right, so now we're back into the ID for the application. So just to show you quickly how this was implemented. So here's our switch. When we activate the switch, we will activate the location sensor. And by activating the location sensor, it has an event called on location changed that gets fired. And when the location sensor turns on, it knows how to collect the latitude and longitude of the location of the device. And then we take the latitude and the longitude and we pass it to maps.google.com, and then we display that map information on the web browser component. And then for the geocoding class, we can create an instance of this geocoder class. And from the geocoder class, we can pull off all of the geocoding information. And that's where we can collect the country code, the country name, the locality, and all this other great geocoding information. All right, so that was a quick look on how to create an C++ Builder multi-device application and deploy it directly to an iOS 64-bit device using the FireMonkey FMX framework. All right, next, let's look at using C++ Builder with common libraries, the runtime libraries. So now C++ Builder has several hundred functions, macros, and classes that you can call from within your C++ programs to perform a wide variety of tasks, including low and high level I/O, string and file manipulation, memory allocation, process control, data conversion, math calculations, and so much more. So for example, the system header contains most of the runtime library functionality. And from the system header, we have runtime libraries for functionality like Bluetooth support, device sensors, and another runtime library called system threading header file. And from the system threading header file, we can use the parallel programming library that's included inside of the system threading library. So now let's take a look at a C++ Builder example showing how we can use this system threading header file with the parallel programming library. So here we are back in the C++ IDE. So here's a C++ Builder project that uses the common runtime library in a multi-device application. So because it's multi-device, again, we can deploy this to Android, iOS, Mac OS X, including the Windows platform. So in this application, we've added the system threading header file, which allows us to use the parallel programming library. So this application finds the number of prime numbers between 1 and 5 million, and then we'll calculate the time to find those prime numbers in two ways. We're first going to use the classic serial for loop, and we're also going to do the same thing using the parallel loop that's part of the parallel programming library. So let me first run this application, show you what it does, then we'll come back in and take a look at the code. So for now, I'm going to build this as a Windows 64-bit application. So again, let me build and run it as a Windows 64-bit application. So now when I click the for loop button, this is using the serial version of the for loop. So we see it took 880 milliseconds to find 348,000 prime numbers. Now, doing the same using the parallel for loop, we see now using the parallel for loop from the parallel programming library, it only took 279 milliseconds to find the same 348,000 prime numbers. So looking at the user interface, we have one button. So this for loop button launches the serial version of the prime number calculations. So when I click on the for loop button, we see it's using the regular for loop. that uses the serial version of the for loop to find the prime numbers using this isPrime function. And when we select the parallel loop button, here we see we are using the key parallel for method from the parallel programming library that comes from the system threading header file. And this launches the parallel version of the prime numbers calculation. And then lastly, for the user interface, I have this memo box that we use to display the calculations. So let me just run it one more time and show you how this works again. So the regular serial loop and the parallel for loop. So it's obviously to see that it's clear that the T parallel for method is much more efficient and runs the application much faster since it makes use of the available CPUs for running procedures in parallel. So now this virtual machine I'm using for my Windows partition is using 4 processor cores. So we can see by using the T parallel for method, the application basically runs 4 times faster because of my 4 processor cores. If I had 8 processor cores on this partition, you would see this application run 8 times faster. Another nice feature of using this parallel programming library in the system threading header file is that there is a thread pool that self-tunes itself automatically based on the load on the CPUs. So you don't have to care about creating or managing threads for this purposes. All right, so that was a quick look on how to use common libraries, the runtime library, in a C++ Builder application for C++ development. Next, and for this last section, we're going to take a look on how to use C++ Builder with platform APIs. So specifically, we're going to look at how to use the iOS APIs to obtain the Apple operating system name, the device type, and the OS version from an iOS 64-bit device. So some folks refer to this as being able to touch the metal of the device, meaning having access to the low-level APIs of the device. So the C++ Builder runtime library includes a number of header files that provide C++ interfaces to both the iOS frameworks and the Android frameworks. So for the Apple iOS framework using C++ Builder, these headers are scoped with iOS API, and for Android, the header files are scoped with Android API. So now let's take a look at a C++ Builder application that uses the platform APIs for an iOS device. So here we have a C++ Builder multi-device application that's using the platform APIs from this header file called iosapi.uikit. And this is a header file we need to use to be able to pull off iOS device information. So by including this header file in our application, so now when the user clicks on this button, I call this button the button Get Device Info. This now allows us to directly access the iOS class. So this is iOS's own UI device class. And from this iOS UI device class, I can get the current device information, and from the current device information, I can get the OS name by calling the device system name. I can get the OS version by calling the device system version, and I can get the device type by calling the device model. So that's pretty exciting about being able to get to, low-level iOS and Android API calls by including the needed header files into my application. And for the UI design, it's basically a button, and then I have a list box with 3 list box items that will display the operating system name, the device type, and the operating system version. So likewise, I want to do this for my iOS 64-bit device. So similar to how I did with the location demo, I can build, run, and launch this application to my iOS device. But to save time, I've already done that. So this application is already sitting on my my iOS device. So let me just show you what it looks like running on the iOS device. So here's my 64-bit iOS iPad Air. So here's the iOS device info app installed on my iOS device. So on the iPad, I'm going to click that icon, iOS device info. It launches the application. So here's what the UI user interface looks like running on my iPad iOS device. And if we go back to the IDE, here's what the UI looks like in the designer. So in the upper right-hand corner is where I have my little button to run the application. So I'm going to click on that little button in the upper right-hand corner, and we see it immediately returns back the OS name, which is iOS, the device type, which is iPad, and the OS version, which is, I'm running 13.4.1 on this iOS device, so that works fine. So this was a quick look on how to use C++ Builder with platform APIs. So the key takeaway here is you have access to the low-level API calls on iOS devices, Android devices, Mac OS X, including the Windows platform, if you need direct access to the platform APIs. All right, so what's new in C++ Builder 10.4? So 2 days ago, on Tuesday, May 26th, we released a new C++ Builder 10.4 product. So now the most productive C++ app development toolkit just got better. So with every new C++ Builder release, we focus on improving the quality throughout the entire tool chain for the compilers, the linkers, and the debuggers. And we focus on compatibility with popular C++ libraries. So let's take a quick look at some of the new main features in the new C++ Builder 10.4 product. So first, the C++ Builder 10.4 product includes a new Windows 64-bit C++ debugger. So this gives you better evaluation and inspection for debugging. And specifically, there's a technology called Formatter that allows you to work on complex types like the standard template libraries for types like vectors and maps. So this new Windows 64-bit C++ debugger greatly improves the debugging experience. Next, C++ Builder 10.4 has expanded C++ library support. So the C++ Builder compilers have been tested and certified to work with many more popular C++ libraries. So for 10.4, for example, we added the library libsimdpp, nemer2d, and SDL, the simple direct media layer. And that's a cross-platform development library designed to provide low-level access to audio, keyboard, mouse, joystick, hardware, using the OpenGL or the Direct3D. And we've added other libraries to the C++ library support that you can access using the built-in Get It Package Manager feature inside of C++ Builder. So we've also updated the Boost library support, and we also made improvements to CMake and the runtime library in this new C++ Builder 10.4 release. Plus, in addition, there are many more C++ enhancements we made in many areas of the product, such as generating debug information, language extensions such as properties and closures and exception handling, and improvements to the free and nil signatures, and many, many more enhancements. So C++ Builder 10.4 is available, so feel free to download and evaluate if you want to use any of the cool features we saw in this session presentation. All right, so this ends the time I had to show you C++ development using C++ Builder with 3 levels of development: components, common libraries, and the platform APIs. So now let's open up this webinar to any questions you might have.
Yeah, I have a few here. Let's see. I heard you say C++ Builder also features C-Lang enhanced compilers. What do you mean by enhanced?
That's a very good question, so thank you for asking. So first, let me mention that C++ Builder includes 6 separate compilers. So there's a Windows 32-bit Clang enhanced compiler, and then there's another 32-bit Clang enhanced compiler that uses Clang command line flags. There's a Windows 64-bit Clang enhanced compiler, an iOS ARM Clang compiler, and another iOS ARM 64-bit compiler, and an Android ARM compiler. So inside the box, there are 6 native compilers that get used depending on what target platform we want to deploy to. So the C++ Builder Clang enhanced C++ compilers are based on the open source Clang project, which means they are an entirely new code base benefiting from input from hundreds of developers. So now we extended this open source Clang project compiler ourselves with support for specific C++ Builder features that we offer, such as the properties on components and the events on components, and other features that work in our ecosystem. And that's what we mean by a Clang enhanced compiler. And the C++ Builder Clang enhanced compilers offer many significant improvements compared to the previous generation C++ compilers that we included inside of C++ Builder. So by using the Clang enhanced compilers, you now get much safer coding using the new, safer, and more expressive C++ features. You get faster performance for compiled code. So we've seen up to twice as fast just by rebuilding your applications using Clang compared to the older classic Borland compiler that used to be in the IDE. And you get so many more specific features. So for example, such as the C++ Builder Clang Enhanced C++ compiler, they're also preprocessors when you run them with the -E switch. And the C++ Builder Clang Enhanced C++ compilers enforce template two-phase lockup. And there are many, many more enhancements by using the C++ Builder Clang Enhanced C++ compilers. And if you want to take a look at all the features, you can visit our C++ Builder DocWiki page and search for Clang Enhanced compilers in the current C++ Builder product, and you'll see the list of all the enhancements we made to the Clang project. All right, hopefully that answers your question.
Excellent, thank you. Let's see, next question here is any information about when Linux will be supported too?
That is a great question. So we do publish a public roadmap. So I can't speak for the R&D folks or the product managers. So the best I can say is check our public roadmap. So I believe we do have it shown on the public roadmap, but I can't tell you when and where and what release Linux support will be added.
Okay, next question. How do you get a link to the RTTL runtime library on your taskbar? What link is needed for this RTTL icon you have on your taskbar?
So runtime library on my taskbar. So I'm not really sure what you mean by that question. So for the runtime library is part of the common libraries. So for example, we go back up a few. So the runtime library is part of the common libraries. So just by adding the header file for the runtime library you need, like system sensors, system Bluetooth, system mat, that gives you access to those functions and methods inside the runtime library for the common libraries. So for example, in the C++ code, I added system threading to access the parallel programming library. I added system sync ops. That gives me access to the T interlock method for thread safe operations. And I added the system diagnostics header, which gives me like a stopwatch type of functionality to be able to calculate the time to do these calculations.
Good, I hope that answered the question. Next question, any successful large applications?
So yes, so from the C++ customer base, we have customers that have 4 million, 5 million lines of code in medical applications and financial applications with large 4 million, 5 million lines of code. So I'm not sure what you mean by large, but it's typical to have C++ Builder applications in the 4 million, 5 million lines of code. And C++ Builder is large memory aware space. So it's able to build and link these large code bases, 4 million, 5 million lines of code.
Great. I got some more clarity on the RTTL question. What he meant was the icon on your taskbar. Where does it link to?
The icon on my
to get an overview of the RTL runtime library.
So my taskbar. So again, I'm not actually sure about the question. So maybe if you send it to me separately, I'll be able to follow up with you. So C++ Builder does include, runtime type library support. So that's included in the when you build the applications, it includes the RTTL support that's used for debugging purposes.
I got some more clarity here. He means the P which is left of RX.
The P is left of RX. Unfortunately, I'm still not understanding the question.
There, I think, the very, very bottom.
Oh, this RX?
Yeah, I think it's the one next to it.
Here, so what I'm running here is the Rad Studio product. So right now I'm running Rad Studio version 10.3, and Rad Studio includes both the C++ Builder product and the Delphi product. So if you only want the C++ Builder product, there's a standalone C++ Builder IDE you can purchase, or you can purchase a standalone Delphi IDE, or this RX icon you see here stands for Rad Studio, which is both the Delphi IDE and the C++ Builder IDE. All right, so now I understand what you mean by the RX.
Let's see if we have further questions here. Does C++ Builder have a Win64 C++ debugger?
Wonderful. So if you recall, at the end of the presentation, I mentioned some of the new main features inside of the new C++ Builder 10.4 product. So the answer is yes. So C++ Builder, the current release 10.4, does have a new Win64 C++ debugger. And the good news about this new debugger, it gives you better general debugging, such as evaluation, inspecting variables, etc. Plus, it has support for better evaluation of complex types, like the standard template library collections and strings for things like vectors and maths, being able to easily debug inside of vectors and maths and maps to get the information that's inside of those types of collections.
Great. Another question I just got in. Easy opt-in but hard opt-out?
So please repeat that question again.
Let's see. It says easy opt-in but hard opt-out. Is it a vendor lock-in?
So again, let's see. Let me take a look if I could see that question, because I'm not understanding that question.
I can try and send it to you. I send it to you now.
Okay, let's see it. All right, I am not seeing the question. Let's see. Oh, here we go. Easy opt-in but hard opt-out. Vendor lock-in. So no, there's no real vendor lock-in with C++ Builder, because it uses standard C++ code and standard header files. So you can easily take C++ code from any other product or any other vendor and drop it inside of C++ Builder, and it will understand that C++ code and that header code. And another nice feature of C++ Builder, it fully supports the command line CMake utility. So you can put your C++ and header file code inside of C++ Builder, and then use the command line CMake utility to build the application without needing the C++ Builder IDE. And that's also a nice improvement we made inside of the new C++ Builder 10.4 product. So one of its aims was you can download any C++ project, let's say from open source projects like GitHub, and then you can use its own CMake file untouched to create the library you need and then simply use that library inside of a C++ Builder application.
Excellent.
Hopefully that answers your question.
I think that's the final question, unless anyone pops up in the next few moments. Yeah, I think we're good.
Wonderful. So I hope you all appreciated this quick look at C++ development using C++ Builder. So what's nice about it is, I try to describe it as 3 levels of development using the pre-built components for rapid application development. Then you have access to these common libraries, the runtime libraries. And then for low-level code, to get down to the specific platform APIs of the devices, either Windows, iOS, Mac OS X, or Android, you have access right down to the specific platform APIs if you need them.
Great. Thank you so much, everyone, and especially you, Al. Very good presentation.
My pleasure. This was a pleasure doing this.
Perfect. We appreciate the time you spent with us now, but it's time to wrap up AlphaSoft Online C++ Demo Day. I hope you found the day interesting and useful. If you have any questions or thoughts about today's webinar or about the software that has been used and demoed today, please do not hesitate to contact me or my team. I will make sure that you have my contact details here. Here we go. We will send out all the recordings, also including all the Q&A questions from the day in about, I would say, 1 week's time. Once again, thank you, Al, for the presentation. And now it's time to end AlphaSoft Online C++ Demo Day. I wish you all a very nice day. Bye-bye.